the last periodic trend we want to talk about is electronegativity. And just to define it up here at the top, basically, electronegativity is a measure of a tendency of an atom to form a bonding pair of electrons. Let me see. Scientists use that electronegativity difference between two atoms to define the type of bond that occurs between two atoms. So electronegativity basically is how likely is that element to bond with other elements. And really, we don't just talk about the electronegativity of one because it's two or more bonding together. We really want to talk about the difference in electronegativities because a different type of bond will be formed depending on the type of the difference in the two electronegativities. And you'll see on the next sheet, I'll just do a brief right here. But there are periodic tables that list the electronegativities of all the different elements, except for these, because they're so rare and don't last for very long that you can't measure it. But you see, for all of these elements, you can see what their electronegativity is. So anyway, depending on the electronegativity difference, tells us what type of bond we have. So you can see here we have a carbon and a hydrogen bonded together. These are their electronegativity numbers. The difference between the two, if you were to use a calculator and subtract that, is 0.35. Okay. Carbon and hydrogen form what is called a non-polar covalent bond. And we'll come across over here and define what that is. A non-polar covalent bond basically occurs between two nonmetals, but when both atoms are pretty equally electronegative, so they've got about the same tendency to form a bond. We call that bond this non-polar covalent bond. While you're writing that down, I'm going to turn my phone off. So non-polar covalent bond. That was a text from Miss Wilson, by the way, just FYI. So in this non-polar covalent bond, which we will talk about more in unit 6 or 7, I don't remember, the electronegativity difference is less than 0.5. So they're about equally likely to form a bond with each other. Basically, non-polar means that it's neutral. And covalent means that they're sharing electrons. So neutral and sharing electrons when the electronegativity difference is less than 0.5. And we come down here and we look at this is between hydrogen and fluorine. And you can see here the electronegativity difference when you subtract 4 minus 2.2 is 1.8. So much bigger than this 0.35 we had over here, right? When the electronegativity difference is in this range, we call that a polar covalent bond. Covalent because they're still sharing the electrons. Polar because what happens here is we end up with an uneven sharing of those electrons. Because this electronegativity is higher, the electrons spend more time hanging out over here and less time hanging out over here. So because they're more often over here, we end up with a negative charge on this side of the molecule and a positive charge on this side because this number is higher. So they'll end up hanging out over here a little bit. They're still shared between the two, but gives a slightly negative charge over here. So a little more about polar covalent bond. When one of them is more electronegative than the other, like we had over here, 4 versus 2.2, The atoms share those electrons unequally, just like I just talked about, right? EQAL. Okay. Sometimes I have to stop and spell. Sorry. So there's an unequal sharing, and what that's called a polar covalent bond. In this type of bond, I'm going to abbreviate it because I'm tired of writing it. Anyway, electron pairs pulled towards the electronegative atom. The more electronegative atom will end up having a negative charge. Charge. Just like I said over here, because the electrons are hanging out over there, right? The less electronegative atom will have a partial positive charge because the electrons are hanging out less over there. They don't like it as much. They're more over here. Right? So this type of bond, the electronegativity difference somewhere between 0.5 and 2 to define this polar covalent bond. The third type of bond we have down here is usually between a metal and a nonmetal. And you see this very large electronegativity difference. It's 3.07. These are called ionic bonds. And basically what happens is the electronegativity is so strong over here and so weak over here that sodium basically just gives the electron away to fluorine. It's just like, here, you take it. I don't want it. It is much more stable over here. Because when we talk about valence electrons, remember, sodium just has 1. Fluorine has 7, right? So fluorine wants that electron so bad, and sodium is more than happy to give it away, right? So we end up here with a positive ion, and over here a negative ion, because remember now it's given away that electron, so it's got a +1 charge. So it says right there. Fluorine has taken that electron, given it a -1 charge. Then what happens? Positive and negatives attract. So they're bonded together, right? Sodium gave fluorine something it wanted, so they developed this relationship. So they're now bonded together. But unlike up here where everybody shared electrons, down here, sodium just basically gives it up. I don't want it anymore, you take it. And fluorine is more than happy to. Right? So let's fill in the definitions. So if one atom is very much more electronegative, than the other, the electron pair is pulled all the way over. So the electron comes all the way over here, no longer shared. So that's when we have this ionic bond, not a covalent bond. And this happens if electronegativity difference is more than 2. So if it's greater than 2, that difference, which here it's 3.7, then you get this ionic bond. So let's look really quickly at the trend. So, like I showed you this before, it has all the electronegativities listed. Here's the trends. Electronegativity decreases as you go down a group. You can see the numbers. 2, 0.98, 0.93, 0.8, 0.8. It's going down, right? The reason that this happens is because there's more energy levels. Remember, more energy levels as you go down a group. And so the atom's nucleus has a weaker, let's go with weaker, yeah. A weaker pull on the electrons. Okay? Remember that electronegativity is a tendency to want to grab onto the electrons. So as you go down, that tendency to want to hold on to them decreases because they're further away. So it decreases because they're further away. that electronegativity increases as you go across, right? Like you can see it right here in this chart. Increases as you go across because just like everything else, as it goes across, there's more protons. Protons. And they are pulling on those electrons. Ooh, sorry, y'all. There are more protons. More protons in the nucleus pulling on those electrons. So they want those electrons. They're going to pull them closer. So the electronegativity will go up because they want to grab onto those electrons. So the most electronegative atoms on the chart are up here in the upper right hand corner. So fluorine, I'm just going to do the symbols: oxygen, nitrogen, chlorine. Those are the most electronegative atoms. These four right here. Now you can see they're the ones that are all above 3. Fluorine even is at 4. Krypton also can form some chemical bonds, but not very often because it's a noble gas, and so it doesn't really like to do that. These helium, neon, argon you see don't have any at all because they're not going to form a bond. It's just not going to happen. But the most electronegative are these four in that upper right-hand corner.